Okay, so we'll be talking about the difference between process shutdown, process shutdown, and emergency shutdown. Okay, so we already know what a shutdown is since we do that almost every time when we turn our computers off. A shutdown is basically shutting the system off entirely, and a regular shutdown has differences between these shutdowns, the process and emergency shutdowns, mainly because process and emergency shutdowns are done in order to prevent accidents or major mishaps from failures occurring. Okay, so before we proceed to that, I'll show an example of a diagram for an emergency shutdown system. Okay, so as you can see, that an emergency shutdown system has lots of detectors and sensors in order to identify if something wrong is happening within the system. So if ever the system detects that something is not right, something is out of normal safe parameters, then it'll immediately shut down that system that is malfunctioning before the accident occurs or as the accident occurs if ever the problem was not detected earlier. Okay, so before we'll get into that, let's talk about the difference. Let's talk about process shutdown first. Okay, so process shutdown, okay, it is done in order to mm, prevent an accident from occurring. The keyword for process shutdown here is to prevent. So, uh, in light of that, process shutdowns, uh, if ever you notice that part of the system is starting to malfunction, and before that system malfunctions entirely and causes an accident, a process shutdown has to take place in order to turn that system off and to fix that problem. Now we have things like that occurs. Malfunctions occur because um, components of a system of a machine has a reliability which can be represented by what's called the bathtub curve. Okay, so this part here is the useful life period. So during this period is where that component of the system is where it is most useful. After that, it starts wearing out, and as it does, the failure rate goes up. And if the failure rate goes up, you are beyond the useful life of that component. That means that malfunctions are bound to occur. And whenever that happens, process shutdown is your friend if you need to shut the system down to fix the problem. So what are the actions? What does process shutdown do? Okay, so we have actions. First is it shuts down the whole system. Process shutdown can shut down the entire system if ever the malfunction is found to be widespread. Then you can shut the whole system down in order to mitigate the problem or to prevent the problem from furthering and to fix it. You can also shut down part of the process. So if ever the problem can be isolated to only a specific part, then you can shut down that specific part. And then you can also process shutdown. Part of its actions is Also to depressurize a certain part of the process. For example, um, if the malfunction is occurring in a line or a component of the system that handles high pressure, then before you can work on that high pressure component, you must first depressurize and then shut down. Okay, so now let's proceed to emergency shutdowns. So if process shutdown is to prevent, emergency shutdown is to mitigate, to prevent for process, and for emergencies to mitigate. What it means is that if the accident is already occurring as a result of a malfunction or something else entirely, an emergency situation, then an emergency shutdown is done in order to keep the damages, keep the problem from worsening. Okay, so uh, again, mitigate. In other words, to minimize the consequences. Okay, minimize the consequences of uh, an emergency situation. So here are the typical actions of an emergency shutdown. Okay. So firstly, it can shut down part of a system or an equipment. Similar with process shutdown, it can also shut down only a specific part if ever the issue is isolated to only that part. Okay, then it can also isolate hydrocarbon inventories according to my resource here. Okay, so you can also isolate hydrocarbons and isolate electrical equipment, because if ever, for example, it's a fire, then of course you have to isolate those, as they can be either the cause of the fire, or for example, fire can be worsened by these components. Okay, and then of course, because we are minimizing the consequences, then an emergency shutdown also prevent the escalation of an event. Okay, so in order to minimize the consequences and minimize the damage, we must prevent the isolation, uh, rather prevent the escalation of the problem itself. So back to our example, which is a fire, then to prevent, to do an emergency shutdown, we have to uh, do what we can in order to prevent the fire from growing and becoming worse. And then action 5, if we're isolating the hydrocarbons from the equation, in, like I said again, in a fire situation, for example, then we can also prevent hydrocarbon flow if ever these chemicals or these substances are flowing in the system, which can lead to the worsening of the emergency situation. Then we also depressurize. Again, similar to process shutdown, there are situations where we need to depressurize the system in order to prevent further damages from occurring. Seventh is emergency ventilation. For example, if uh, harmful gases, gases that can be harmful to the workers in an area. Then we have to activate our emergency shutdown process may also activate the emergency ventilation system in order to keep everyone safe. And lastly, close doors. Okay, so emergency shutdown systems may also close doors. What this means is, for example, in an event where a water handling plant has a malfunction, they can close watertight doors in order to prevent flooding from occurring. The system can also close fire doors in order to isolate a fire within a specific part of a system and prevent it from spreading to the other parts of the system or even the other parts of the plant. So those are the actions of emergency shutdown. In order to summarize everything, here is a handy infographic. One moment. Why is it? Here we are. Okay, so this graphic here can clearly differentiate between process shutdown systems and emergency shutdown systems. Okay, so process shutdown here, for example, in this graphic, you can see the normal values are down here. So these are the expected values within the system. If malfunction starts to occur, then you do process shutdown. Process shutdown in order to prevent the worsening of the problem, so that you can immediately mitigate and fix the problem. So that's why the curve is going down. Or if the failure has not been detected in time, and a mishap is about to occur, then in order to keep the system safe and to keep everyone in the plant safe, emergency shutdown has to be done in order to prevent an absolute outbreak, which is, well, undesirable. Okay, so this is to conclude the differences between process and emergency shutdown.